video, we will be performing a chi-squared goodness of fit test. Please take a minute to read the prompt. After getting trounced by your little brother in a children's game, you suspect the die he gave you to roll may be unfair. To check, you roll it 60 times, recording the number of times each face appears. Do these results cast doubt on the die's fairness? Test an appropriate hypotheses and state your conclusion. So here are the results of your 60 rolls. Notice here the number 1 showed up 11 times out of your 60 rolls. The number 2 showed up 7 times out of your 60 rolls. And again, here are the results of your 60 rolls. In a chi-squared goodness of fit test, we have to write out both our null and alternative hypotheses. Our null hypothesis is a statement of no change or no different than what's expected. Well, what do we expect to happen? We expect that this dice is fair. So our null hypothesis would be the dice is a fair die, okay? Or the die is fair. Our alternative is different than what's expected, or in this case, the die is unfair. Take a second and write that down. We then have to check our conditions. There are 2 conditions with the chi-squared tests. The chi-squared goodness of fit test and the chi-squared test both only have 2 conditions you have to check, and that is the randomness condition and the expected count condition. Well, clearly, whenever you roll a die, the die roll is each die roll is random and independent of every other die roll. And in this case, if we roll a die 60 times, assuming that the die is a fair die, and that was our assumption, our null hypothesis, the die is fair, we'd expect each side of that 6-sided die to come up about 10 times. 60 divided by 6 is 10. So that's what's called our expected counts. So our 2 conditions is randomness and expected counts. So die rolls are random and independent of each other, check. And our expected counts are all greater than or equal to 5. And clearly 10 is greater than or equal to 5. And what I did over here is I recreated the table up above, and I just put our expected counts next to each observed count. You don't need to recreate the table. You can just write in right over here on the worksheet, right next to the number 11, put the number 10. Right next to the number 7, put the number 10. And at the top, you can label that column EXP for expected value. This column we call the observed value. So normally we label that OBS for observed. The next step in our hypotheses test is the mechanics. Take a look at your AP formula sheet. At the bottom of page 1 on your formula sheet, you should see the formula for chi-squared statistic. This is the symbol for chi-squared, this little funky x with the little exponent 2. Okay, it says chi-squared equals the sum of observed minus expected squared divided by expected value. So we take each pair, right? So we take 11, the observed value, minus 10, we square it, and divide by 10, which was our expected value for the number of times we'd expect the face with 1 dot on it to appear on this dice. And then we would do 7 minus 10 squared divided by 10, and then 9 minus 10 squared and divided by 10, and then 15 minus 10 squared and divided by 10, etc., etc. Right? We're adding all those up. And again, you don't need to show every single component of the chi-squared statistic. Each one of these is called the chi-squared component. You just have to show that you understand how to plug into the formula. So I showed the first 2 and then the last one, and I put plus and then dot, 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 and plus to show the AP readers that I understood how to plug in to the chi-squared statistic formula. So this is the work you must show in order to get full credit on the free response question. I would now like you to take a minute. I'd like you to take out your calculator. I'd like you to put your observed values in list 1 and your expected values in list 2. I would like you now to go to Stat. I'd like you to arrow over to Tests. And if you could arrow up, and notice you see chi-squared goodness of fit test. Well, how do you know if it's a chi-squared test or a chi-squared goodness of fit test? Chi-squared goodness of fit is whenever we have one variable data. So in this particular prompt, our one variable is the die. Is the die fair? That's what we're studying. It's one variable. So whenever we have one variable data, we're going to use chi-squared goodness of fit test. So arrow up to chi-squared goodness of fit test. Notice it says, did you put your observed value in list 1? Yes, we did. How about your expected values? Are they in list 2? Well, yes, they are. Our degrees of freedom for a chi-squared goodness of fit test is always number of cells in our original table minus 1. So in this case, we had 6 cells in our original table. Those would be right here. Let me show you. The 6 cells are these 6 observed values. 1, 2, 3, 4, 5, and 6. These are the 6 cells of data in our original table. So our degrees of freedom is the number of cells minus 1. So 6 minus 1 is 5. And then we can arrow down to calculate. And notice we get our chi-squared statistic, which is 5.6. We get a p-value of 0.347, which we know is extremely high. They tell us our degrees of freedom is 5. And then we get the chi-squared contributions, all those individual additions, right, when we plugged into that chi-squared formula. So please take a minute and write down this information. This is everything you would need. This step here, the chi-squared statistic, the p-value, and the degrees of freedom. These are the 4 things you would need in order to get full credit for the mechanics. And now we're on to our conclusion. And of course, we have an extremely large p-value. And we know when our p-value is larger than our alpha level of 5%, we are going to fail to reject the null. If p is large, we fail to reject the null. And there's insufficient evidence of the alternative. So for this prompt, we would say with a p-value of 0.347, larger than an alpha equal to 0.05, we fail to reject the null hypotheses. There is insufficient evidence to support the claim that this die is unfair. And that's it. Tune in again for the next episode of Miss Max Academy.